here is a case study about logical design of IoT. So logical design of an IoT refers to an abstract representation of the entities and process without going into low-level specification to the implementation. So it consists of IoT function block, IoT communication model and IoT communication APIs. So first, IoT function block. An IoT system compares of a number of functional blocks that provide the system and the capabilities for identification, sensing, communication and management, devices, communication, services, management and security application. So devices that provide sensing, monitoring and control function. Communication blocks handle the communication systems. Services. An IoT system uses various types of IoT services such as services for device monitoring, device control service, device public servicing and device discovery. So management block provides various functions to govern the IoT system. Security functional block, security IoT system and providing functions such as application, authorization message and content integrity to data security. Application. IoT application provides an interface that user can use to control and monitor various aspects of an IoT system. Application also allow users to view the system status and analyze the processed data.
Communication model. Request response, public subscribe, push pull, exclusive pair. Public response is a communication model that involves publisher, brokers and consumers. Publisher are the source of the data. Publisher sends the data to the topic which are managed by the brokers. Publishers are not aware of the consumers. Consumer subscribes to the topic which are managed by the orders. When the broker receives data from the topics from the publisher, it sends the data all the subscribes and consumers.
Push and pull. It is a communication model in which the data producers push the data queues and the consumers pull the data from the queues. Producers do not need to be aware of the consumers. Queues help in decoupling the messages between the producers and consumers. Queues also act as a buffer which helps in situations when there is a mismatch between the rate at which the producers push the data and the rate at which the consumers pull the data.
Exclusive pair. Exclusive pair is a bidirectional, fully duplex communication model that uses persistent connection between client and the server. Once the connection is set up, it remains open until the client sends requests close to the connection. Clients and servers send messages to each other after connection set up. IoT communication APIs. REST-based communication API, work-socket-based communication API.
First, we are going to see about REST-based communication API. Representation state transfer is a set of architectural principles by which you can design web service and web API that focus on the system resources and how resources states are addressed and transferred. REST API follow the request-response communication model. REST architectural constraints apply to the components, connectors and the data elements. The REST architectural constraints are client to server, stateless, cache-able, layered system, uniform interface and code on command. Next, we are going to see about WebSocket based communication API. WebSocket API is a allow bidirectional full duplex communication between the client and server. WebSocket API follows the exclusive path of the communication model. Unlike request response, WebSocket API allow the full duplex communication and do not require new communication to set up each message to be sent.